Krishnachandra Sahu, Jagyasini, Pooja Sahu, Lipun Sahu, Madhusmita Sahu, Sujata Raut. Sahu title is very important. All are Sahu. Sujata Raut, Nirupama Jamuna, Priyabrata Patnaik, Alok Kumar Sahu, Pritam Rao, Saraswati Barar, Somaranjan Swami, Pritam Rao, Satranjan Patra, Girija, Amrita Naik, Jagyasini Sahu, Subhasmita Behra, Arpita Subhadarshan Sahu. Already it is 6:05, so why you are so late? Before class start, someone has given dislike. Whether that student knows whether that sign is for dislike or like, I don't know. Like me, if you inform to the other students in your group, it will be better for you, because matrix is also in your BSc syllabus. "51 students are watching and 31 likes and 1 dislike. Hello. The number of dislikes increases. It increases from 1 to 2. Okay. So today I'll start matrices. and the most easiest chapter in class 12th and also in BSA or BTech also. And you should secure full mark in this chapter. Okay, so if you will not get full mark from this chapter, it will be very difficult to clear the paper. Okay, see what is matrix? Matrix simply, it is a rectangular arrangement. It is a rectangular arrangement in which the elements are arranged in certain rows and in certain columns. The elements should be arranged in certain rows and certain columns, and that rectangular arrangement is called a matrix. Okay, that means the matrices are denoted by capital A, B, C, D and so on. I am not writing the definitions because the definitions are all in your book. So it is unnecessary to write the definitions. I will clearly tell you the definitions and I will give you some examples so that you can understand. ABCD matrices are denoted by capital ABCD and so on. And if there are m rows and n columns, then the order of the matrix is m by n. It is read as m by n, not m cross n. Don't say m cross n or m into n. It is m by n. One very important thing. If you say what is the size of this board, the carpenter will say that 6 by 5 or 5 by 4, 5 by 4, 5 by 4, 6 by 5, like this. He is saying that by maybe his education will be class 3 or 4th, but we are saying that m cross n, m into n. No, it is m by n, but the symbol is into multiplication symbol, but you should read as m by n. Clear? So, and always write m. M is the number of rows and n is the number of columns, and first number should be row and second number will be column. Row by column, not column by row. Row by column, always row by column. Remember, row by column. The order of the matrix is row by column. That means if it is 2 by 3, then 2 rows, 3 columns. If it is 4 by 5, then 4 rows, 5 columns. If it is 3 by 3, so 3 rows, 3 columns. If it is 1 by 2, 1 row, 2 columns. Clear? So this is the order of the matrix. Now, how to represent the matrix and how to write the matrix? See here, I am writing 3 by 3 or I am writing 3 by 3. It will be better for you. It is A11, A12, A13, A21, A22. I am writing slightly in the larger form so that it will be better for you. A11, A12, A13, A21, A22, A23, A31, A32, A33. And the matrices are denoted by either by square bracket or you should write like this, or you should give parallel lines. But generally the authors are not writing this form. They are writing either square bracket or parenthesis. Clear? And this is a matrix and denoted by capital A let, and you should write here the order. This is 3 by 3, the order, you should write here 3 by 3. And this matrix in a compact form, it is written as Aij, put a square bracket and write the order 3 by 3. This matrix can be written in this form. And question is that what is A11, A12, A13, 1, 2, 1, 1, 2, 1, 2, 2? What is the meaning of this one? Aij, see here, Aij, this is the element of ith row and jth column. That means I is the row, number of row, and j is the number of column. I have told you, you should first write row and then column. That means this is first row, this is second row, this is third row, this is first column, this is second column, this is third column, and this element means first row, first column, first row, first column. So A11, first row, first column, and this one first row, second column, column 1, this is column 2, first row, second column, and this one first row, third column, first row and column is third column, and this one second row and first column, this one second row, second row and column is 2, this one row is 2 and column is 3, so 2 3. So this one third row, so 3, and first column, so 3 1, and so on. And that means Aij is the element of ith row and jth column. Ith row and jth column. Clear? And always write the row first and then column. Okay. Now, I am giving you an example. Construct a matrix of order 3 by 2 where Aij is equal to I plus j. Aij is equal to I plus j. So let the required matrix be capital A is equal to, how many rows are there? 3 rows and 2 columns. 3 rows and only 2 columns. Columns is 2. That means A11, A12. Because the number of columns is 2. You should not write further. 2 columns are there only. A3, A21, A22, A31, A32. Like this. A11, A12, A21, it is 21, 22, 31, 32. Clear? 3 rows and 2 columns. So here you should write 3 by 2. And given Aij equal to I plus j. In the question it is given that Aij equal I plus j. That means sum of these two I will given. So therefore capital A is equal to I plus j. 1 plus 1, it is 2. 1 plus 2, it is 3. 2 plus 1, it is 3. 2 plus 2, it is 4. 3 plus 1, it is 4. 3 plus 2, it is 5. So this is the required matrix. So this is the answer. Clear? Another question. It will be 2i plus j. Aij is equal to 2i plus j. So order is same 3 by 2. So this is the required matrix and given 2i plus j. And 2i plus j means, tell me, 2i plus j. 2 into first one plus j. 2 into first one plus j. See here. Aij is equal to 2i plus j. That means 2 into first one plus j. 2 into first one plus j. So 2 1 is 2 plus 1. It is 3. 2 1 is 2 plus 2. It is 4. 2 2 is 4 plus 1. It is 5. 2 2 is 4 plus 2. It is 6. 2 3 is 6 plus 1. It is 7. 2 3 is 6 plus 2. It is 8. So answer is this one. Is that clear to you or not? Hello? Is that clear to you, all of you, or not? Okay. So next we will see what are the different types of matrices. See here, I want to tell you what are the application of matrices. If you will apply matrix in optics chapter, in physics, in optics chapter, if you will apply the method of matrices, then the 4 pages derivation will be reduced to 2 pages. And if you will apply matrices for solving equations, it will be very easy. For equation solving, method of matrix method is very, very easy. Clear? So matrix chapter is actually really it is very important, because without matrix you cannot clear the BTech also. In BTech or BSc or MSc or MTech, it is very, very important. Clear? See here, types of matrices. Types of matrices. And the first one is row matrix. What is row matrix? Row matrix means only one row. One row only. Only one row. There is no restriction on column. That may be 2 column, 3 column, 4 column, 7 column, any number of columns. So order is how much? What will be the order? In order to write the order, number of rows by number of columns. So number of rows is 1, so 1 by n. This is the general form. Order of a row matrix is 1 by n. And what is the example? One row. I have told you one row. A, B, C. Only one row. Row is 1 and column is 3. Clearly, see here. Row is 1 but the number of columns is 3. So it is 1 by 3. Clear? Another example. 7, 5, 2, 4, 3. Row is 1 but the column is 1, 2, 3, 4, 5. So 1 by 5. So this is all about the row matrix. Row matrix means single row but there is no restriction on number of columns. Okay. Now column matrix, second, number 2. And in column matrix, only one column. Only one column. That means the order will be, who can tell me? Only one column, and the column is written in the second part. So n by 1. Column is 1 and the number of rows, there is no restriction on the number of rows. Example I am giving you. Because the number of columns is 1 and the row is as many as you can take. How many rows are there? 3 rows and column is 1. So you should write row first. So row is 3. So 3 by 1. It is in this form, n by 1. So 3 by 1. And if I will take 1, 2, 3, 4, 5. How many rows are there? 5 rows are there. And column is 1. So 5 by 1. So this is all about column matrix. Clear? Then rectangular matrix. What is the rectangular matrix? What is the meaning of rectangle? Practically, what is the meaning of rectangle? Rectangle means like this. This is rectangle, but this is a square. This is a square, but this is a rectangle. That means length is unequal to breadth. That means number of rows is unequal to number of columns. Number of rows is unequal to number of columns. Number of rows is unequal to number of columns. If the number of rows is unequal to number of columns, then the corresponding matrix is called rectangular matrix. Clear? So that means, example I am giving you, A, B, C, D, E, F. This is a rectangular matrix because the number of rows is 2 and the number of columns is 3. So 2 by 3. Here both are different. These two are different. For rectangular matrix, these two number of rows, number of columns should be unequal. I have told you. So for example, 1, 2, 5, 6, 7, 1. Number of rows is 3 and the number of columns is 2. So 3 by 2. This is also a rectangular matrix. Clear? So under what condition a matrix is said to be a square matrix? Tell me. Who can tell me? Jagyosena Sahu is telling that for entrance or board. What is your necessity? Hello? See here, in square matrix, number of rows is equal to number of columns. Number of rows is equal to number of columns. That means a very important point I am going to tell you. A square matrix of order 3 I am taking. That means 3 by 3 order. A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. This is a square matrix of order 3 by 3. Clear? Here the number of rows is 3 and number of columns is 3. I am going to tell you very important points. So this is the diagonal of the matrix. Not this one. Left hand top to right hand bottom. Left hand top to right hand bottom. This one. In which I is equal to j. I is equal to 1, 1, 2, 2, 3, 3. I is equal to j. And these elements are called diagonal elements. That means A11, A22, A33 are the diagonal elements. That means in diagonal elements I is equal to j. And this is the diagonal of the matrix. And above the diagonal, see here, this part, see here, this is the upper part above the diagonal. Here I is less than j. Clear? And below the diagonals, this part, here I is greater than j. There are 3 parts. In a square matrix, there will be 3 parts. Middle portion in which I is equal to j. These are the diagonal elements, and this is called the diagonal of the matrix or leading diagonal of the matrix. And above the diagonal, in these elements, I is less than j. See here, I is less than j, I is less than j, I is less than j. And below the diagonals, in this case, I is greater than j. You should know this relationship. Okay. See here. Now, your diagonal matrix. And already I have told you A11, A22, A33, these are the diagonal elements, and the other elements are called non-diagonal elements. A11, A22, A33, A44, these elements are called the diagonal elements. And the other elements in which I is unequal to j, are called the non-diagonal elements in case of square matrix. Clear? In case, that means in a square matrix, AII, that means if I is equal to J, II, these are the diagonal elements. And if Aij, where I is unequal to J, these are called the non-diagonal elements. Clear? Now, what is a diagonal matrix? If I will tell you that who is Rama or who is Hari, who is Mr. Patnaik? First of all, Mr. Patnaik is a human being, or you may say a living being, or if we will ask you define a human being, that means you should say a living being is said to be a human being if these conditions will satisfy. First of all, a human being is a living being, then there are certain conditions which he must satisfy. Similarly, what is a diagonal matrix? A diagonal matrix, it is a square matrix. It is a, first of all, it is a square matrix, because in case of square matrix there is only diagonal. In non-square matrix there is no diagonal. Clear? So in square matrix you will get the diagonal only. So it is a square matrix in which non-diagonal elements are all 0. Here, diagonal elements are not 0. The non-diagonal elements should be 0. That means like this. Here, A, 0, 0, 0, B, 0, 0, 0, C. Like this. This is a diagonal matrix. Except the diagonal elements, all the elements should be 0. That means the non-diagonal elements should be 0. This is the definition of diagonal matrix. You should follow like this. After square matrix, I have taught you diagonal matrix. That means diagonal matrix is a square matrix in which the non-diagonal elements are 0. And this is written as like this. DIAG, diagonal. And you should write systematic way. A, B, C. A, comma, B, comma, C. Like this. Like this you should write. This matrix is denoted like this. Diagonal matrix whose diagonal elements are ABC. You should maintain the order. If you write BAC, this will become B, this will become A, this will become C. You should write the order like this. If this is A, this is B, this is C. So first of all you should write A, then B, then C. Okay. Now, what is scalar matrix? Scalar matrix, it is a diagonal matrix. It is a diagonal matrix in which all the diagonal elements are equal. It is a diagonal matrix in which the diagonal elements are equal. That means like this. In which I am writing in a short, in which all the diagonal elements are equal. That means like this. K 0 0 0 K 0 0 0 K. This is a scalar matrix in which the diagonal elements are same. That means this is a particular case of diagonal matrix. Scalar matrix is a particular case of diagonal matrix. Clear? Now, identity or unit matrix, and the symbol is I. It is a scalar matrix you should define like this. That means they should be interrelated. It is a scalar matrix in which the diagonal elements are unity. What is the meaning of unity? Unity means one. I am not writing unit, unity, ty. That will be like this. For order 2, you should write 1 0 0 1. And for order 3, I am writing I3. I3 means for order 3, 1 0 0 0 1 0 0 0 1. And for order 4 like this, similarly I4 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So this is a unit matrix of order 4, this is a unit matrix of order 3, this is a unit matrix of order 2. Clear? Why it is said to be unit matrix? Can you tell me? Because if you multiply or identity, what is the in real analysis or real number, 1 is the multiplicative identity, because if you multiply 1 to any number, the value does not change. Similarly, this matrix is called identity matrix because if you multiply I to any matrix, the value does not change. That is why it is named as unit matrix or identity matrix. Clear? Then zero matrix. Very important point I am going to tell you here. In your book, it is written as null matrix or void matrix. Don't write null matrix or void matrix. This concept has been proved wrong last 15 to 20 years before. But the authors are not corrected your books. Okay, so because I am telling you the reason. Null means empty. Now, whether this is a, see here, null matrix, null set, this is a null set or void set, empty set. Null means empty, void means empty. Empty set or null set or void set. Now, whether this can be a matrix? No. How many rows and how many columns are there? There is no columns, no rows. So this cannot be a matrix. So that is why, because 0 is a real number. 0 is a real number. If you put a 0 inside a set, the cardinality is 1. But if you write like this, the cardinality is 0. There is no element. But here there is an element and it is 0. Clear? So you should write 0 matrix, not null matrix. Clear? So 0 matrix means all the elements are 0. All the elements are 0. The matrix in which all the elements are 0 is called 0 matrix and is denoted by O. Clear? Or 0 you may read also. This is 0 matrix means 0 0 0 like this. This is also 0 matrix. 0 0. This is also 0 matrix. So 0 0 0 0. This is also 0 matrix. It is of any order. This can be of any order. I am not written that 0 matrix is a square matrix. Square matrix, then diagonal matrix, then scalar matrix, then unit matrix. Clear? And 0 matrix, there is no restriction on the order. It may be of any order. Now, the triangular matrix. And triangular matrix are of two types. Lower triangular matrix and upper triangular matrix. And what is lower triangular matrix and what is upper triangular matrix? You should see carefully. And in low triangular matrix, it will be like this: A 0 0 This will be B, C, 0. This will be D, E, F. Up to this much I am taking. Why it is named as a low triangular matrix? Who can tell me? It is named as low triangular matrix because the lower part forms a triangle. See here. The lower part forms a triangle. That is why it is called low triangular matrix. Clear? And in case of upper triangular matrix, it is A, B, C, 0, D, E, 0, 0, F. Here, the upper part forms a triangle. See here. The upper part forms a triangle, here the lower part forms a triangle. So that is why this is called low triangular matrix, this is called upper triangular matrix. And what are they? How can you write or how can you define this one? I have told you A11, A12, A13, A21, A22, A23, A31, A32, A33. In these cases, I is less than j. I is less than j. Already I have told you. That means here Aij equal to 0 for I is less than j. That means the elements in which I is less than j, those elements are 0. That means above the diagonal. All the elements above the diagonal are 0 because I is less than j, I is less than j, I is less than j. So these elements are 0. And here Aij equal to 0 for I is greater than j. That means the lower portion. I is greater than j, I is greater than j, I is greater than j. So this is the definition of upper triangular matrix and lower triangular matrix. Do you understand or not? Hello? Is that clear to you or not? Upper triangular matrix, lower triangular matrix. It can be any matrix. Priyavata matrix, Patnaik. There is one row and one column. See here, I have told you. There is no restriction. I am writing n by 1. I am not given that n is unequal to 1. But the number of columns should be 1. If the number of column is 1, it is said to be column matrix. And it is 1 by n. N may be equal to 1. So if it is 1, 1, 1 row, 1 column. So you may say it is a row matrix or it is a column matrix. There is no restriction on this one, on this element. Clear? So now, under what condition two matrices are said to be equal? Who can tell me? Under what condition two matrices are said to be equal? Can you tell me? See here, very interesting thing. Aij and B is equal to Bij. I have not written the order. And here, equal matrices. I am going to tell you the definition of equal matrices. Under what condition two matrices are said to be equal? Under what condition two matrices are said to be equal? Clear? The first condition is that order must be same. Order of A is equal to order of B. This is the first condition. Clear? And the second condition is Aij equal to Bij for all I and j. That means A11 must be equal to B11, A12 must be equal to B12, A21 must be equal to B21. If you write 21, here also 21. 3, 3, 3, 3. 4, 4, 4, 4. 4, 1, 4, 1. 3, 2, 3, 2. Like this. Clear? So, let us give an example. Find X, Y, P, Q such that x plus 2y, x minus y to p plus q and p minus q is equal to 1, 2, 0, 4. Clear? So this matrix will be equal to this matrix. I have told you, here the order is 2 by 2, here the order is 2 by 2. First condition is satisfied. And under what condition two matrices are to be equal? The corresponding elements should be equal. You should say corresponding elements should be equal, not elements are equal. Don't say elements are equal. If you say elements are equal, see here, very interesting thing. In my classes, all the students are saying that, sir, same element. A and B should contain same element. See here, what is the interesting thing is that 1, 2, 2, 4, 3, 2, 3, 1, 4. Same element. Here 1, 2, 3, 4. Here also 1, 2, 3, 4 are there. Both the matrices contain 1, 2, 3, 4. But this matrix cannot be equal to this matrix. So you should use the word corresponding elements should be equal. Corresponding element means A11 must be equal to B11, A22 must be equal to B22, A21 must be equal to B21 and so on. Clear? So here x plus 2y must be equal to 1 and x minus y must be equal to 2 and 2p plus q is equal to 0 and p minus q equal to 4. Clear? So you have got 4 equations, and if you solve these 2 equations, you will get the value of x and y, and if you solve these 2 equations, you will get the value of p and q. Can you tell me the values? Can you tell me the values, 4 values, p, q, x, y? Abhishek reactions. Abhishek, what is your question? Is there any doubt? You have forgotten the question. Okay. Now, under what condition two matrices are said to be similar? If they have same order. Similar, not equivalent. Under what condition two matrices are said to be similar? If they have same order. Okay. That means 2 by 2, both will be 2 by 2 or both will be 3 by 2. Then the matrices are said to be similar. And now question is that scalar multiplication of a matrix your matrix is singular MATRIX matrix and this matrices is plural. Clear? So don't confused. See here, capital A is equal to Aij having order m by n, and k is a scalar. Scalar means any constant. Root 2, root 3, 2 by 2, 2i. It may be a complex number, it may be a real number. Clear? It may be a complex number also. Don't think that it must be a real number only. It may be a complex number also. So if you multiply k to a, that means ka. K into matrix A means that k should be multiplied to each and every element of the matrix A. That means k into aij, whose order is m by n. I am giving an example. If A is equal to x, y, p, q, then what is 2a? 2 means you should multiply 2 to each and every element. 2x, 2y, 2p, 2q. And now very interesting thing is that while multiplying, you are multiplying to each and every element. So while taking common, you should take common from all the elements, not from one row or one column. Because you are not multiplying to one row only or one column only. You are multiplying to each and every element. So if you want to take common from a matrix, so you should take from each and every element. Clear? So if you want to take common from a matrix, then you should take common from each and every element of the matrix, because while multiplying, you are multiplying to each and every element. Clear? So is there any doubt up to this much? Up to this much, is there any doubt? Whether we should proceed or not? Hello? Whether today I will proceed further or not? Okay, see here. Now tell me whether you should do the problems from your book or I will give you questions. Whether you should do from your book or I will give you some extra questions. Soumyaranjan Jana. Okay. Okay, I will give you some extra questions in the description. So you can do from your book or you can do the extra questions also. Okay, I will give you. See here, addition of matrices. How to add our two matrices? If A is equal to Aij having order m by n and B is equal to Bij having order m by n, and for addition the condition is that the order must be same. Two matrices can be added if their order is same. That means matrices can be added. matrices can be added if they have same order. That means here the order is m by n, here the order is m by n, and the corresponding elements should be added. While adding, a plus b is equal to aij plus bij. That means the corresponding elements should be added and the order should be remain same. I am giving you an example. See here. Here a is equal to x, y, p, q, r, s. And b I am writing, b is equal to alpha, c, d, e, f, g, like this. Here the order is 2 by 3. Here the order is 2 by 3 because 2 rows and 3 columns, 2 by 3, 2 by 3. So these two matrices can be added. So therefore a plus b is equal to, I have told you corresponding elements should be added. That means a11 should be added to b11, a12 should be added to b12, a13 should be added to b13, and so on. So this element should be added to this element, x plus alpha, then y plus c, p plus d, q plus e, r plus f, s plus g. So this is the value of a plus b and the order is 2 by 3. Clear? So this is all about matrix addition. And now let us see what are the properties it must satisfy. Properties for addition of matrices. And the number one property is it satisfies the commutative axiom. Commutativity. That means it satisfies the commutative law. That means a plus b is equal to b plus a. The value of a plus b must be equal to the value of b plus c because 2 plus 3 is equal to 3 plus 2. Clear? So there is no difference. Then associativity. That is, if ABC are three matrices having same order, for addition I have told you the order must be same. A, B, C should be of same order. Clear? So a plus b plus c must be equal to a plus b plus c. That means first add a with b, then the result should be added to c. And in this case, first b and c should be added and then a is added to b plus c. The result will be same because 2 plus 3 plus 5 will be equal to how much? 2 plus 3 is 5, 5 plus 5 is 10. And if you write in this way, because the elements should be written in this way. Clear? So 2 plus 3 plus 5 equal to 2 plus 5 plus 3 is 8, so which is equal to also 10. The result will become same. Okay. So second property is associativity, and the third property is identity. Identity matrix. That means now, please tell me which matrix should be added to any matrix so that the value does not change. 1 minute, please. 2 plus which element is equal to 2. That means which element should be, which real number should be added to 2 so as to give 2. That means the value does not change. So 0. 0 is the additive identity. So in this case now tell me which matrix should be added to any matrix so that the value does not change. Who can tell me? Zero matrix. Very good. See here. A plus 0 matrix is equal to 0 matrix plus A is equal to A. That means 0 matrix is the identity matrix. That means additive identity. Not multiplicative identity, it is the additive identity. Because I am giving you an example. A is equal to 2, 3, 7, 5. And 0 matrix is for this one 0, 0, 0, 0. Now A plus 0 is equal to 2 plus 0 it is 2, 3 plus 0 it is 3, 7 plus 0 it is 7, 5 plus 0 it is 5, which is equal to A itself. That means A plus 0 is equal to A. So 0 matrix is the additive identity. Clear? Now additive inverse, fourth property, additive inverse. Here A is equal to 2, 3, 5, 6. Clear? Which element should be added to A so as to give the identity matrix 0? Who can tell me? Which matrix should be added to A so as to give 0 matrix? Minus A. Okay. That is why I have told you first scalar multiplication of A matrix. You can see here 2, 3, 5, 6 is here. If you like minus 2, minus 3, minus 5, minus 6, if you add this one, you will get 2 minus 2 it is 0, 3 minus 3 it is 0, 5 minus 5 0, 6 minus 6 it is 0, which is equal to 0 matrix. And this matrix, if you will take minus 1 common, take minus 1 common, you will get 2, 3, 5, 6. And what is this? This is the matrix A, that means minus A. So minus A is the additive inverse of A. Minus A is the additive inverse of A. Because if you will add minus A to A, the result will be 0. A plus minus A will be equal to minus A plus A will be equal to 0 matrix. Not 0, 0 matrix. So A plus minus A is equal to minus A plus A is equal to 0 matrix. Here minus A is the additive inverse of A. Remember, minus A is the additive inverse of A. Clear? Then another cancellation law. A plus first one, A plus C is equal to B plus C implies A is equal to B. That means you can cancel out C from both the sides. Okay, and this is the right cancellation law. And number 2, C plus A is equal to C plus B implies A is equal to B. Left part can be cancelled out. C. Here C is on the right of A and B. So this is called right cancellation and this is called left cancellation. Clear? So if you write like this, A plus C is equal to C plus B, then you cannot do anything. You cannot cancel out C. Clear? So first of all, apply the commutative axiom. That means A plus C is equal to B plus C. Then you should cancel out. Or you may apply commutative axiom to this one. You can write C plus A is equal to C plus B. Then left cancellation you can apply, so that you will get A is equal to B. Okay. Now I have already told you about scalar multiplication. For example, A is equal to 2, 3, 4, 5 and B is equal to 0 1 2 3, find 2a plus b. You have to find out 2a plus b. That means 2 into this one plus b. And this type of question was set in your state board. Perhaps it was 2 mark question. Clear? So 2 into this one 2 3 4 5 plus b 0 1 2 3. So multiply 2 to each and every element. 2 into 2 is 4, 2 3 is 6, 2 4 is 8, 2 5 is 10 plus 0 1 2 3. Now 4 plus 0, 4 plus 0, it is 4, 6 plus 1, it is 7, 8 plus 2, 10, 10 plus 3, it is 13. So answer is this one. Clear? Now how to subtract two matrices? Are you feeling bored? Hello? Are you feeling boring? Okay, thank you. Only this one. After that, I'll end this class after subtraction. Then the next class I will teach you about multiplication of two matrices, which is very important. That means it will take some time. Okay, so that is why I will teach you in the next class. Because again I will take the live class at 9. So after this I will finish, because I have completed perhaps 2 exercises. Okay, so see here, if A is equal to Aij having order m by n and B is equal to Bij, again for subtraction also the condition is that the order must be same. Two matrices can be subtracted, but actually practically there is no meaning of subtraction. For example, A minus B, it is not A minus B, it is A plus minus B. Already you have read in class 3/4. This can be written like this, A minus B in class 6, sorry, in class 6 you have read A minus B can be written A plus minus B. Clear? So that is why in addition, for addition of two matrices, order must be same. Similarly, for subtraction, order must be same. So same procedure, A minus B means the corresponding elements should be subtracted. That means Aij minus Bij having order m by n. Because actually A minus B can be written as A plus minus B, and A is one this one, and minus B means minus Bij, then add these two, you will get this one. Okay, and I am giving an example. 2103 minus 5712. So what is the result? 2 minus 5, this is minus 3, 1 minus 7, minus 6, 0 minus 1, it is minus 1, 3 minus 2, it is 1. So this is your answer. Clear? So this is all about addition, subtraction and scalar multiplication, and I will give you the questions. So and have you all completed your indefinite integration? Hello? Have you all completed indefinite integration? Okay. Okay, thank you. So, thank you for watching my class. Okay, good evening or good night also. Not good evening, good night for you, because my next class is at 9 and it is not for you. Okay, that means for plus 3 students it is, but for plus 2 students it is good night, and for plus 3 it is not good night. Okay.